Ladies and gentlemen, welcome back. You are watching Overland Weekly. I think this is episode 16. I hope that's right. My name is Davey. I am joined tonight by my friend and tonight's co-host, Mr. Zach Johnson, who
Good seeing
is
Davey.
one of... What's up, buddy?
See
Zach
if we
is
can
one
have
of the
some fun now.
proprietors. I'm talking over each other. I was going to say Zach is one of the proprietors of Rocket City Cruisers down in Huntsville, Alabama. You've got the Rocket City shirt on tonight, don't you?
Yeah, just stay working and then come in here and do this. So
Awesome. So Zach, you just got back from a little event. You may remember Zach was with me at our Merry Band of Idiots escapade at Mardi Gras a couple of weeks ago, and then you drove. How far was that? 6-7 hours to go to Arkansas?
about 7, a little under that, but yeah, fuel and stops and whatnot. So yeah, about 7 hours.
Yeah, and that was to Southern Cruiser Crawl. Tell us about that.
Yeah, so Southern Cruiser Crawl, it's at Hot Springs Off-Road Park. Used to be called Superlift in years past, but it's about 1,200 acres. It's very dense on trails, so anything from drive in with your very basic trail rig all the way up to the biggest and the baddest, and they're still getting installed. So we covered about a third of the trails. We went up there with 3 trucks worth. We're all about the same capability and the same willingness to crash into stuff, and had a great time. So once all the videos get processed out, we'll get some stuff up.
Speaking of crash, I heard our buddy George went for a little ride.
He did. He went for a little ride. The transfer case decided to pop out of 4-wheel drive and rode into 2, and he was on a bad little gatekeeper, and he didn't notice it and took a little tumble. So he's okay. The truck's okay. 30 minutes after the flip, we drove it out, but he got a little shaken up.
Yeah, the cage did its job, but if anybody's got a 40 windshield and frame, I bet he might need one.
He'd be very grateful, especially if it's in tan.
Yeah. If you don't have to paint it, even
Right.
better. Well, Zach is with me tonight because we were talking earlier and we were texting about something else and somehow got on the topic of portals. And I said, hey, I'm talking to Matt and Scott from Portal Pros on the show. And you said, I would really like to come on and talk to them because I want to geek out on portals too.
Yeah, absolutely.
So welcome to tonight's show, Scott and Matt from Portal Pros. Hey guys, how we doing?
Oh, doing great.
You guys are both in San Jose area in California, right? So,
Yeah.
Beautiful. And so, unless you've been under a rock for the past few months, you've seen these guys, or you've seen one of their reels or some of their content somewhere. It's fallen in everybody's feed, and I know out on the West Coast they've been making the rounds at the events as well. So we really need to figure out how to get you guys east of the Mississippi, so maybe we can meet up in person and see these portals.
Absolutely.
Well, I won't have my Jeep, but I will be in Tennessee this coming weekend because my parents live outside of Nashville. So.
See, yeah, there you go. Well. You can bring that 3D one with you and let me 3D printed one. I can check that out.
Sneaking the whole portal on the plane might be a little tricky.
I was going to say, I wonder explaining that to TSA. Yeah.
You don't understand. Davey really needs to see this.
Yeah. And so we'll get into that. I know you guys had a big time at King of the Hammers, and Trail Hero just wrapped up. And right before we started recording this, I was looking at your YouTube feed, and I see, new video from Portal Pros, welding the diff on day 1 at Trail Hero. Go ahead and give us that rundown.
Yeah. So, Matt and I went out to Trail Hero, I guess about 2 weeks now. We drove the Jeep out there. We did bring Matt's truck with a trailer as well, planning on something going wrong, but it's about 650 miles. We drove out there and it was like 100 degrees the whole time. So it was a good workout for the portals getting out there. And then, the next day we went out to actually hit some trails, probably within like 20, 30 minutes, we were on an obstacle and realized the rear locker wasn't engaging. So we kind of like, backed off, tried to, click it on, click it off, turn the car off, turn it on, just to see like would it actually engage. And it's a stock JK Rubicon e-locker.
Okay.
So, we're trying to figure it out, whatever, and then realized it definitely was not turning on. And then went to do a quick diagnosis, check like, are we getting 12 volts to the connector or whatever? No. So, yes, we are. So it's like, okay, it's something internal. So then we called Holly Fowler from Mischief Maker. She's got a shop nearby. So we went over there, took it apart, and basically determined that the actuator, like the solenoid part, crapped out, which I guess is common in those, that they just die. It's 10-year-old axle. So I guess those things go out after a while.
I mean, Toyota guys never have this problem.
Never. Yeah, right. Yeah, exactly.
Yeah. That's a joke. Yeah.
No. so yeah, same thing. And we were like, well, we're here for 3 more days, and we want to do some, pretty gnarly trails. We got to have, like, the front locker was working, but we got to have the rear locker working. So what can we do immediately to get going to go do a trail run tomorrow morning? And there's just a slider that's like outside, or it's part like next to the carrier, and you just push that over by hand and it locks it. And we're like, okay, well, that looks like steel, and the case is some form of steel or iron or whatever. So we can just tack it locked in place. So we just put like 5 or 6 tack welds right on there and turned our e-locker into a spool, basically.
Yeah, at that point it was
drove it the rest of the week like that.
It was far more important to get the portal testing, and also us going wheeling was way more important than street drivability. So we said, yeah, we'll take it.
Yeah, it chirps a little in the turns, whatever, no big deal. I still went and picked up pizza right after we did that. It's still a grocery getter.
I love it. So you guys had the Wrangler, your test rig out there, but give us the rundown, because I know before that rig, you guys each have a personal rig that you've built over the years, and I believe that's kind of how you all met. So give us the personal rig rundowns.
Okay, go ahead, Scott. You want me to start?
Okay, you can start. Yeah.
All right. When I got out of college, the first thing that I did was decide I needed a reliable vehicle. Because at the time I was driving an 85 El Camino back and forth to work at my new big kid job.
Nice.
So my choice in reliable vehicle was 2000 XJ. Axle swapped on 37s with Detroits. Certainly not a good choice in reliability, but it has been a whole lot of fun. So I've had that one for going on almost 10 years now.
Okay.
Wheeling it, breaking it often, upgrades. I haven't really changed much on the axle side, but added a roll cage, did a whole bunch of other modifications to it. And yeah, I've been beating on it since then. The one behind me, for those on video, about 3 years ago, I picked up a 67 Jeepster Commando, and have been, in that time, have had a kid, and the build kind of got put on hiatus for a little while, and I just kind of chip away at it when I get time. But it's currently in running and driving condition, which is awesome for me. But it's an LJ frame, 1-ton axles. It'll have 40-inch tires, coilovers, the whole bit. So
a 5.3 motor.
Yep, the 5.3 truck LS, and we're still deciding on transfer case. It's got a 241 in it right now, which I think I want lower gears. So evaluating what the options are. But yeah, it's running and driving, but it needs probably another, at my pace, 2 years worth of work before it's wheelable. With a second kid, it's definitely it's going to be a challenge getting it done. But work on it here and there, so it's good.
And then mine was a 94 Grand Cherokee ZJ. And then when I bought it, it had 35s and Dana 44 axles with air lockers in it. And then the hammers 2 or 3 years ago, I got a little spicy, chipped a tooth, one of the spider gear teeth in there. So I decided I needed some bigger axles and bought some 2006 Super Duty axles. So the Dana 60 front and the Sterling 10.5 rear. chopped off all the brackets, added, did our own custom suspension brackets, everything like that. And then air lockers, 538 gears, and it was running on 37s. So yeah, that thing was pretty bad. Also, homebrewed roll cage and every other upgrade you can think of, hydro assist, all that stuff. And then I just sold it to, just like literally 2 or 3 weeks ago, sold it to a buddy of ours, because, got to fund this company and the next Jeep and whatever. So okay. yeah, it was a great Jeep. I mean, it did chocolate thunder. It did, had all kinds of like crazy obstacles over the years. So yeah, it was pretty sad to see it go, but at least it'll be around. So
now, was this the V8 CJ or was this the inline 6? Yeah. Reliability.
Yeah. Yeah.
Maybe.
Off and on.
Fortunately, that's the only thing in the extra that has been reliable is the 4-liter inline 6 for me.
Yes.
A little underpowered because I think something else is wrong with it, but it runs, gets you on the trail and gets you home.
Nice.
Good deal. So you guys both have some pretty good technical background, obviously, you play in the rocks and whatnot. You got some pretty good engineering backgrounds as well. What's your experience inside of manufacturing with custom fab? And then Scott, with your time at Apple, what's got you guys shaping your approach to this whole Portal Pros deal?
Yeah, so we both went to Cal Poly San Luis Obispo, which is a state school in California, and studied mechanical engineering. That's how we actually originally met. I started a year before him there, and we joined the Baja SAE Club. And so it's basically like you build a little dune buggy, kind of like the old Honda Odyssey single-seat dune buggies. And it's literally, they give you a motor. It's just a Briggs & Stratton, like 12 horsepower motor, and then a rule book, and you build a car around that. And, we could get, it would go like maybe 30, 35 miles an hour. So it's not like totally crazy, but it's also like, I was learning how to TIG weld and I welded the chassis, like the tube frame. It's like, so anyway, yeah, that's how we both kind of, or at least for me, Matt had been a little bit more involved in fabrication stuff before that, but for me, like I had never touched a welder, never touched a mill, a lathe, anything like that. So throughout that, it was like learning how to, start with a manual mill or manual lathe, and then that escalated to CNC mills and lathes. And so by the end, we were building, like in college, we designed a forward neutral reverse gearbox for that car. Got the gears made at Advanced Adapters, actually, because they were like kind of a local company to San Luis Obispo. Did all the machining other than that ourselves. And yeah, that was where we like really definitely cut our teeth in getting into like more high precision manufacturing stuff.
Nice pun.
I keep doing that.
It's just not even intentional at this point. It just happens.
Yeah, I know. Oh God. Yeah. And then so fabrication, machining, all that stuff. And then I started working at Apple right after school. And I thought I was like total hotshot when I was in school, knew how to run CNC machines, and like relative to our peers, maybe I was a hotshot. But then you get into industry, and like the first or second project I worked on was one of the iPhone enclosures. And we were ramping to a max volume per day of like 300,000 iPhones per day, which is like 5 or 10 a second, something like that. So instead of being in charge of like one CNC machine, I was in charge of 20,000 all of a sudden. So yeah, that was just one supplier, that wasn't even every iPhone that year. Right. So that was like a really steep transition to go from, working on our own stuff in the shop to like producing at that volume. Not to mention like the quality control and the dimensions we were having to maintain and everything. So carrying that into Portal Pros, it's kind of a nice like mixture of things. Like from the Apple side, the understanding how to work with suppliers, because we're not doing any of this in-house because we're literally running this out of our 2 garages, and we don't have any machining equipment or anything. So knowing how to evaluate suppliers, how to set up quality control systems, how to get into mass production, like how to drive a schedule. So, like we said before we started the recording, it was, we started the company in January. We already have prototypes and we're hoping to ship to customers by April. So less than a year and a half, and we go from like an idea to a product shipping that's a fairly complex product. Like all that really came from Apple and like learning how to do that stuff. And then at the same time, we're also doing all the installations ourselves. Like before jumping on the podcast, I was downstairs pulling the differential out so that I could cut the tack welds off so I could get it back to being an e-locker. So, that combination of skills, like knowing how to be in the shop, working on things, fabricating, taking things apart, it kind of is like a perfect set of skills that we have to put into Portal Pros to get this thing going. So, yeah.
Yeah, my background's pretty similar to Scott's. Obviously, yeah, we met in school and did the same Baja Club there. And then I've been working in very similar industry doing high volume manufacturing stuff. And my background or job for the first 5 or 6 years of my career was literally R&D CNC machining. So we were an outsourced supplier. We had a supplier that had, they give us quoted times for how fast they can produce our parts and what schedule they can meet. And my job was literally to be in California in front of a CNC machine, the same one that they had in China, and figuring out how can I make it faster myself and then start to ramp up volume here and then show them, hey, this is how fast I want you to run it. These are the feeds and speeds, everything else. Exactly the steps that I want you to see when I go to the factory, when I visit you. And then making sure that we like negotiate that with suppliers and say, hey, this is my expectation. How do we meet in the middle on where you are with your capability and what I've been able to produce here, back in California. So yeah, it obviously very well translates over to what we're doing now, where it's like we have a product, we designed it ourselves, that we had that skill from in school, and now it's about how do we make sure that we're getting a quality product and we're getting quality parts from the supplier and all of the suppliers we're working with, and making sure that they're on time and keeping track of all that stuff. It has been the easier part, I would say, of starting the business, where I think in most cases, it's kind of the hard part, and it's just about selling it. For us, it's the hard part is all running a business, all the other pieces.
I get it.
Marketing plan.
Yeah, exactly. Yeah. Learning how to be social and talk to people at events and all that stuff.
Oh,
it's a
I
whole
get
new
you.
thing.
I hear you.
Yeah.
It's funny, like, so it's what you said to me, all that stuff you just described, that would be the difficult part. That would be the I have no clue, but I'm not an engineer. There's 3 engineers on this call and 1 non-engineer. So it's funny. But talking about, like you mentioned, the marketing plan. All right. So you come up with this idea, you decide we've got the skills to design this and take this into production. But when did you start thinking about what's our value? How do we fit in the marketplace relative to competition that's here and presumably competition that's coming? Because portals are portals. If you look back over the last 20 or 30 years, I mean, it kind of gained some popularity because there was a magazine article years ago, and you can take these Unimog axles and you can take these portals and this and that, and but I think they're here to stay this time, is what I'm saying. So how do you guys fit into the market with your Portal Pros?
So like what we just talked about, Matt and I have the capability to do like all these, Super Duty axle swaps, 1-ton axle swaps, whatever. And that's like kind of let's say the go-to right now. If you want to go do extreme rock crawling, like you're going to go either buy some aftermarket axles, some 1-tons, or you're going to go to the junkyard and pull them.
Yep.
And we would like to be able to give people an option to, be out there and do these trails, but not have to have those skills. So like go and be able to buy a Jeep and then bolt these things on and put 37s or 40-inch tires, and boom, you're running the Rubicon the next day. So like where we fit in is we see it as like, from a cost perspective, there are great options out there, like performance wise, but from a cost perspective, they're fairly unattainable right now. And so we're trying to use our skills and that kind of thinking around like, hey, we know what can be done today, and we want to kind of marry our manufacturing, our design backgrounds with the, knowledge of how to make something a little bit easier to install and not having to, go through the headache of cutting up a Super Duty axle and spending 15 hours grinding it down, whatever. So yeah, where we fit in is we're trying to be that more cost focused, budget friendly, attainable, however you want to describe it. Portal company, that is really trying to be there for the person that isn't able to afford the crazy expensive high-end stuff that's out there, and maybe doesn't have the skills to do this axle swap in their garage like we do, but with a decent enough set of hand tools, you can install them and put them on there and be out on the trails very quickly. And so that's kind of where we're trying to fit in, is that more budget, less effort kind of approach to being able to go and do the trails that we want to do, and run 37s or 40s or whatever on your truck or Jeep.
Yeah, I call it, I told somebody I call it portals for the people. Like that should be your all's motto. Like,
that would be effective. That's a great tag.
Yeah.
Yeah.
Because, well, like you said, I mean, there's these things, they're not going to be cheap by from a dollar standpoint, just because of the nature of what you're manufacturing. But if, like you said, if you've got a person that they've bought a stock vehicle and now they're considering paying a shop to potentially swap axles, fabricate suspension, and then, maybe even re-gearing as well, where they might decide with the portals that they can leave the gears and the axles alone. It starts being a little more equal in terms of pricing.
Yeah. I think we've definitely seen, I think for those of us that have been in kind of not the industry, but the sport for a long time, you've definitely seen the influx of new people in from, COVID especially, but even a little bit before that. Seeing it grow so much and just knowing that there's a lot of people out there that, like you said, just don't have that skill set or don't want to pay a shop for that skill set, to be able to let them get out on the trails, and do everything that they want to do for a reasonable price is kind of definitely where we're trying to fit in, I guess.
Yeah. And also make it so that you don't have to upgrade so many things. You can kind of do, not that it's a one and done deal, but like, your factory suspension is going to survive longer. Your factory axle shafts, U-joints, the differentials, the drive shafts, like those are all now taking less load. So it's just less stuff you have to upgrade overall. So it's just a kind of overall great package to, be able to just go and wheel without worrying,
Yeah.
Yeah.
So as this grows and you kind of are starting to scale up operations and, like you said, hopefully go into production and have these out by April. I mean, just from a business standpoint, how are you guys funding all of this? Do you have some big outside investor that we don't know about, or is this bootstrapped? What's the plan?
Bootstrap is probably the best term for it.
Okay.
Yeah, you're talking to the investors right now.
All right.
We had some of our own kind of startup capital, I guess you could say, knowing approximately what it would take to kind of get us a prototype, get us out there in front of people and start to build necessarily a brand around it, so that then we can start, reaching out to customers to start generating revenue. It's mostly bootstrapped, and then we're certainly going to get to a point at some point where we're going to be taking small business loan, whatever it takes to get our product to market. You know what I mean?
Yep. Understand.
Yeah. So
just sorry to interrupt you, Zach. I haven't asked, where did the name come from? Because there's always a good backstory to the name. And
except for when AI is a thing.
Oh no, AI.
So you just said, give me 50 options for a portal company.
Literally. Oh yeah, you'd think it would be number 40. No, it was like, hey, I'm going to start to ChatGPT. We're going to be starting a portal axle company, and we want it to have alliteration and it goes, spits out 10 option, first one, Portal Pros. And we were like, yep, that's it. We're done.
Oh, well,
yeah,
it works.
We're engineers, okay? We're not the creative types.
No,
Yeah.
I hear you. I get you. And I'm right there with you. Now, you touched on something a minute ago. I mean, there's a lot of headwinds you're facing coming in with some of this manufacturing, especially from starting on the small end. I mean, I'm familiar with what you're talking about from the machining setups, and even if you're trying to go through the jobber route, it's not a small capital cost. So, what kind of supply chain logistics and manufacturing costs are you guys eyeballing? As this one's going to bite us if we don't get this one pinned down?
Oh, that's a good question. I feel like, so the good thing is, at least our design right now, the way it stands, is it's not really tooled in any meaningful way. So we're not casting anything. It's like billet machine cases. The gears are turned from round stock. And all that is driven by our volume, which is, basically zero right now. And even when we place our first order, it's going to be 10, 20 customers worth, like not that big. So at this moment, it's not huge. The biggest thing has been matching or kicking off tools for broaches specifically for making internal splines, so that we can, and getting those to match. So like we have one supplier that's cutting the gears and we have another one that's cutting our rear axle shafts. And we sent out like, here's the spline dimensions and whatever. And as is typical in going into manufacturing, you have two different suppliers. They're going to the same spec. Well, they don't always match. So we got our axle shafts and then we got the gears and I go to put the shaft into there. It's like, nope. So, and it like, again, we're the kind of guys that are like in the garage trying to figure this thing out. And so I talked to the axle shaft supplier. I'm like, hey, this needs to run this weekend. Like the parts showed up like Tuesday or Wednesday, and we were like, we're assembling it on Saturday, and we are driving this. So whatever's in the way, we're gonna make it happen. So I was like, is it cool if I just use a Dremel and cut the splines a little bit deeper and make it work? And he was like, you have my blessing. So I sat there for like 4 hours and just slowly cut the splines a hair deeper, would check it. Okay, it's fitting in there. Okay, just go a little bit further. Yeah, that was a silly one. But I think we'll have that worked out fairly quickly. So that if that's our biggest problem, it's not too bad.
Yeah.
It's got the tolerancing problems going on, sounds like.
Exactly.
Yeah.
I think part of it too is that when you start to go looking at designing splines and manufacturing splines, there's not like a nice universal standard for like a 32 spline axle looks like this. It's like, well, a 32 spline Jeep axle is this, but sometimes some manufacturers go metric and they change the diameter a little bit. They change the ID of the splines. They change the overall shape of the spline. And it's just like, you got to weed through all of that stuff before you can get to it. Yeah. And then of course, with spline parts and gears, because those are all heat treated, the lead times are longer. That's certainly the one that we're most focused on in the beginning to kind of nail down. I think we've got a pretty good path for it now, but it's definitely one of those like, all right, the machining the cases is like less than a week, but the gears is like, all right, I got to machine the blanks, heat treat it, finish machining it, finish heat treating it, and then grind the teeth or polish the teeth, whatever we want to do, So that one definitely is our gating item, I guess you could say.
Yeah. But thankfully in our prototypes, I mean, other than that, when there's one bearing fitment that was a little off, but other than that, like everything is fit, the gears work, they're not loud. The press fits that we wanted to press in, they press appropriately. So yeah, I mean, I don't know, Matt, anything else that we had a problem with? There's one hole that we spec'd a little too tight. Yeah. The ABS hole was a little tight. So we just used the drill and just by hand drilled them out a little bit.
Yeah.
Like that was our biggest issue, it was like, oh, okay. Besides the spline. So
I think that's,
thankfully
it speaks a little bit to like, okay, we've gone through this process a couple times before, maybe not on portals, but on other design stuff that we've done, and we've done gears and splines and stuff before. So we kind of knew where the headaches were going to be at least, but you don't find them a lot of times until you just start making stuff. And that was the goal, was like, all right, get a design that works and let's just make it, and we'll figure out the rest of it. And then we'll iterate a couple times before we get to customers.
Mm-hmm.
You touched on something there that I was really curious about, because of being the spur driven. Spurs are notorious for being really loud, right? I mean, that's your reverse gear and transmission. They just scream at you. I didn't know if it was just going to be quiet because they're at the long end of the wheels and they're far away from the driver, or if they're just generally that quiet.
So there's one thing we specifically did to try and make them quieter, because we were very paranoid that was going to be a problem. So we, after the gears, so like the process for the gears is you like turn a blank on a lathe, and then you cut the gear teeth, you go through heat treatment, and then we added an extra process where we grind the gear teeth after heat treatment. Because when you heat treat them, everything moves a little bit, even if it's just 5-10 microns, whatever. Well, you're talking about a gear shape, like a tooth shape, that's going to go and slide again. Well, technically not slide, but it's going to roll against another tooth. And if that shape is just a little bit off or a little tweaked, or it's a little bit, pushed, this corner is touching and this corner is not, or whatever, that is where that kind of like noise can come from. So we added that process, and it basically just shaves off a tiny bit of material, but it brings the tooth shape or profile back into spec, and then also increases or smooths the surface, so better surface finish. And yeah, I mean, when we did our first ever, not even test drive, like we had the Jeep on jack stands in my garage. We started it up and put it in 4-wheel drive and just had them spin, just had the portals spin with no tires or anything. And it was for the Jeep JK that we have as the stock exhaust. And if you've been around those things, they're super quiet. The engine noise was way louder than the portals. So they're quiet. And we're like in a 2-car garage, like, yeah, they're very quiet.
I think the other part that gets missed, traditionally you think of that like a manual transmission with straight cut gears. It just howls. Even a transfer case sometimes when they're designed like that, they're really loud. Because we are not the like distance from the driver to the wheel is the difference, but because you're down a path of reduction, the RPM at the portal itself is much lower than say in your manual transmission. Your engine's at 5,000 or 3,000 RPM, whatever it is. Your transmission, one of those shafts is spinning at 3,000 RPM. The portal at 70 miles an hour, the fastest it goes is 800, 700-800 RPM. So because of that, you don't have the howling noise, I guess, because you just don't get up at level. Yeah.
What about, I know you guys, you're kind of using this modular design that works across multiple platforms. But when you talk about multiple vehicles, you've got different, different bolt patterns and different axle weights. And, how do you account for all of that, but still have a system that's modular?
Yeah. So we, pretty early on, we realized, like, as we were starting to design this around the JK, and we were looking at that, like, or do we really want to like pigeonhole ourselves where the whole design is based around mounting to a JK, and then have to redesign the whole thing to make it work for even a JL, which is slightly different. So yeah, it occurred to us that it might just make sense to have some adapter plates that kind of make that work. So then that started like down the road of, okay, we don't want to make this as universal as possible. So that kind of 2 advantages. One, from our side, certainly ramping up manufacturing. If we have fewer different unique parts for different vehicles, that means we can increase our total manufacturing volume, which drives the cost down. It also makes it easier for us to manage and whatever. And then 2, it is great for our customers because it's kind of turns it into like a one-time investment. So, for example, I have them on my JK right now. Well, in 5 years down the road, say I want to betray the Jeep way and go get a Toyota Tacoma or whatever, I can take those portals with me, get new adapters, get new input gear to match the spline count on that CVs, and bolt those things up to my Tacoma and put my old stock parts back in the JK and get rid of that thing. So it kind of like has some serious advantages there. But how, specifically how to execute it, kind of touched on it. We have an adapter plate that would bolt on to where your unit bearing used to be, or onto your rear axle shaft flange. And then we, the input gear spline has to match with whatever CV or axle shaft you're using, which is a little bit different vehicle to vehicle. And then your brake caliper, we just have we have universal mounting on the cases, and then we just have an adapter that mounts to your brake caliper, and then you mount that to the portal. So that pretty much makes it universal. And then our output flange is also swappable. So where the wheel would actually mount to. So you can put a different bolt pattern on there. If you want to run an 8-lug bolt pattern on a Jeep, like that's theoretically possible. Yeah. So it's made it really easy for us to like adapt to different vehicles as we go.
Yeah. So for us, that means, effectively in the worst case scenario, 4 parts. If you don't have the matching input splines, if you're going from Toyota to Jeep or something, worst case, you've got 4 different components of the entire assembly that have to change going from vehicle to vehicle. And for us, that's the cases are the same. Most of the gears are the same. All the bearings are the same. There's no adjustments for changing size or anything. Like it's all, we can then order, say, 100 sets and say half of them are for Tacoma and half of them are for Jeep or whatever we want, and not have to worry about keeping the cases organized and all this stuff. It's just make a portal and then add whatever adapters you need to make it fit onto a vehicle.
You touched on something, second go brakes. That's usually something that, or brakes, and then the major diameter outside of that, you start running into wheel size changes that you're driving them. What's the smallest size wheel you can run on this arrangement?
17-inch wheel.
Makes sense.
Yeah, and the
and
brake,
that's kind of like the standard now. So
yeah,
right.
The adapters that we have designed to are reusing your stock brakes. So the stock brake rotor, stock brake caliper, all that gets retained. So you have your standard stopping power from that. And then if you have upgraded aftermarket brakes, whatever it is, if it fits on the original unit bearing, it'll fit on the portal the same.
Gotcha. So a lot of guys are going to wonder about that if they're going to get forced into 18s or 20s because of the OD change. But
yeah, that was a lot of time for us spent in CAD trying to make sure, like, here's our model of our 17-inch wheel. Let's keep it shrunk within this, range, which makes bearing fitment a whole challenge. But once we kind of got it worked out, we were similarly worried that, like, I don't want to have to go be a very specific wheel for this application. I want to have a lot of options, and 17 is kind of this seems to be one of the standards now. Once you get beyond the 35.
So you guys aren't going to try to force anybody to go buy your special $1,000 a piece wheels to go with these portals, huh?
No comment.
All right, yeah, we'll leave it there.
Actually, I actually do have something to say about that. Not specifically the what you're referencing, but one challenge with portals, like in ours specifically, you add quite a bit of width when you bolt them on to your existing knuckle. So it's 4 inches per side. So we are going to be, and actually we got some custom wheels made for us that are we should have them in a few weeks. That it's basically like super positive offset, so it brings the wheels in like higher back spacing. So that is definitely something that's going to be kind of new to think about. It's like, normally you're running like maybe 4.5 inches back spacing or 3.75 or whatever. We're going to be running 6.5 inches back spacing, and we're still going to be 2 inches wider than the stock wheel mounting surface, basically.
You're just trying to get them to tuck when you twist them up.
Exactly.
Yeah.
Makes sense. The other biggie in there is, there's a lot of mass that's going on when you're hanging off this new box you're creating. There's a lot of iron and there's a lot of steel involved. How are you guys, how are you balancing all this increased weight and what that's doing to durability and performance of the vehicle to begin with versus what they started with? It's considerable. So
yeah. So our portals, each corner is about 50 pounds. So you're adding like 100 pounds per axle, and when you have a solid axle, and that, while that kind of is a lot, when you compare it to what's like, we were talking about earlier, the Super Duty axle swaps. So like a Dana 44 on a Jeep JK, it weighs around like the 250, 300 pound mark, something like that. If you compare that to an 05 plus Super Duty axle, those are like 650 pounds, and people swap those all the time and think nothing of it, so like that's kind of in the back of my mind, that like, we're adding 100 pounds, but we're not adding 300 pounds, and that's already kind of an accepted weight. And we've talked to a couple of shock tuning companies, and they pretty much like, because I had the same concern. I'm like, hey, I want to buy shocks, like, don't I need to tell you about the portals? And he was pretty much like, with a Jeep, like a full size vehicle application, meaning not a side by side or an ATV, something like that. The ratio of sprung to unsprung mass is so high because the vehicle itself is so heavy, and that's what you're actually damping, like with your suspension. Because you're adding unsprung mass like on your axle is typically considered bad, right? Like you have more stuff more mass that has to move up and down going through whoops or whatever. But because of the ratio of sprung mass to unsprung mass in these vehicles, he told me they don't even think about the mass of the vehicle really when in a consumer application, like a non-race application. So he's like, yeah, if you ordered shocks, that we set up for your JK, and then you put portals on, I wouldn't change the tuning at all. So it was like, oh, okay, don't need to worry about that. That's
a really big point then. That's a big point then. If you're arguing that you're trying to leverage the OEM suspension parts, bolt us on, and we've talked to the guys, and you're going to be okay. That's strong. Totally. It's a good thing to bring up.
Totally. Yeah.
I think the other piece,
not only. Oh, go ahead, Matt. Yeah.
I think the other piece of it too that you're always worried about is drivetrain reliability, right? So like,
absolutely,
U-joints, drive lines, things that I have broken many times wheeling, where we wheel.
Even recently.
Yes. Lubricate your drive shafts, people. I'll just.
Yeah.
But that's obviously a big concern. So there's two pieces to that, right? There's the shafts and the things that take torque load themselves, and then there's like the axle housing and everything else, control arms and all that stuff around it. The axle shafts and U-joints, drive shafts, all the things that are taking all of the torque, because the reduction is after all of those things, those are starting to see reduced loading, right? So we have a 1 1/4 reduction. So if you're thinking about your Dana 44 ring gear that's 8 3/4 or whatever it is, because the reduction is after that, your ring gear diameter, your ring gear sees less loading. And I don't know, coin that, but like the effective ring gear diameter is bigger. And the first time I said that, Scott was like, "What?"
But you're accurate.
You're basically,
it's true.
Yeah. You're basically making it 20% stronger by just having less torque going through there.
And then obviously the other part of it is your axle housing is designed for a certain size load. You're adding on this extra leverage and everything else. That's the one area where we're like, okay, the stock stuff, you probably are going to want to upgrade. You're going to want, for a traditional solid axle, you're going to want C gussets. Maybe you want to put a truss on, things like that. Relatively straightforward things that a lot of people are going to upgrade if you're going to do like the heavy rock crawling stuff. If you're doing more overlanding stuff, probably not necessary because the leverage isn't that much. But if you're putting it into big cutouts and wedges in Sand Hollow and you're beating on it pretty good, it's definitely recommended to upgrade, ball joints, gussets, and stuff like that. And on IFS, depends again on what you're doing, but your drive lines and everything are seeing less loading. CV axles now have less angle issues because you're not trying to lift the suspension. Your CV axles are straight, and your lift is out of the portal, which is hugely beneficial for steering angle and everything else. But then, you've got to deal with everything else that you would normally deal with if you're trying to put a 37 on a standard IFS, front suspension setup.
Gotcha.
You talked about the cases. They're billet, right? It's 6000 series. So, what's that decision from? Is it just cost? Is it weight? Is it both? Versus having casting or steel components?
Okay. Well, I was looking at you. No, that's fine. I mean, it's okay, so it's kind of two questions in there, like aluminum versus steel, and then machining or machine billet versus like casting. Aluminum, like we did some amount of analysis on it, but we're kind of looking at what's going on in the industry and in the specific application. Like we just felt that was going to be right. And then from a, going to we're going to billet machine this because our volume is currently zero. We're buying basically bought a one-off part. Like machining a steel piece that is that big would just be very expensive. Just because you have to cut steel generally slower. So that was definitely a consideration. And then, the cast versus billet machine. right now it's just a volume question. As soon as we're hitting some reasonable number, meaning probably, we think we can sell 1,000 a year, something like that, is when we would probably look into tooling, and either die casting or sand casting, something like that. And we'd probably still stick to aluminum. And there may be some slight, strength considerations or whatever that we would add in there, slight, design changes. But that's the direction we'd like to go to be able to drive the cost down further. But right now, I would say it's still an acceptable level of cost that we can sell, and we think we can make money on these things. But yeah, we want to be able to drive the cost down further in the future for sure.
And we've been surprised too when we're looking at costs of, say, casting versus even forging as well. And obviously forging gives you a whole different material properties that can be beneficial in some scenarios. And there is definitely a potential path for us where we end up with forged cases instead, forged and then machined, obviously. So yeah, it's kind of one of those, we're keeping the options open for sure as we go forward. But for now, there's the billet machine. It's working.
Yeah.
Scott, you mentioned 1,000 pieces a year. Do you think that's a one-day possibility with what you guys see the potential market out there?
Well,
we like
it right.
I mean, it's not okay. Let's be honest. This is not a 2025 goal, but
yeah.
A someday goal. Yeah.
When we start to, I think, especially think about worldwide applications. Right. Yeah. Like in the US, there's definitely a certain amount of volume that we could hit. Whether that's 1,000 or not is, up for debate. But when you start to think of, if you sold a few hundred in the US, there's a big market in Australia. We've gotten a lot of outreach from even Africa and then UAE and other areas of the world. If we can start to figure out the logistics for those, which again, I think we've got a decent enough background to start to figure out. I think that's definitely a realistic scenario if we start to hit some of those other markets for sure.
And like, to kind of add to that, I don't know the numbers of these, but how many companies are making aftermarket 1-ton axles? Dynatrack, Dana themselves.
There's
Fusion,
more than a couple, yeah.
There's a lot, right? And they're selling those for 20, 25 grand. And not to mention even like the portal, like the Jesse Haynes portal, which you have to buy the whole axle as well. So yeah, we feel pretty confident that there's a market there, and we're obviously going to be competing with that kind of stuff, and lift kits and whatever. So I think it's definitely a high possibility to be kind of in those kind of numbers.
And when we got into this, like obviously our focus has always been rock crawling. That's kind of been our background, but we're definitely seeing the possibility where it hits the overland market in the right scenario. Right? Like our case currently is designed to be super extra strong for all the rock crawling applications. Maybe as we get further along, there's an opportunity to make a more overland focused case where you still get the lift kit and the gear reduction, which is a huge expense for most people getting into the sport. And you just can put that into a portal instead that you just bolt on. Right.
Yeah. And there's plenty of overlanders that will overbuild and overbuy. And hey,
oh yeah. Well, and the name of the game of, right? Yeah, I was just gonna say the name of the game of overlanding is convenience, right? Camping with convenience. And one big thing that we have that, other portal manufacturers have it too, but you certainly can't get out of a 1-ton axle is a central tire inflation system. So you can just air up and air down while sitting in the driver's seat. And that is like. The market for it's bougie, but the market for just like CO2 tanks and multi-tire inflation systems and faster air compressors, like we're going to be competing with that effectively too, right? So like that's a huge market. So there's I think our overall product is going to be fairly attractive, and I think that the volume will follow for sure.
Talk briefly about the bearing choice. You've got SKF bearings throughout, right? So was this I'm assuming reliability, but maybe also replacement consideration there?
Yeah, I mean, we kind of looked at like the major bearing manufacturers. I think we'd worked with SKF when we were in college, I believe. So it was kind of like in the back of our brains. But Timken or fag bearings or whatever. Like, I mean, I think any of these would be perfectly acceptable. They're obviously in the industry, they're mass produced, whatever. And we decided to stick with that because we'd worked with it in the past, and just feel pretty confident it's going to work. Don't have to worry about it so much.
Yeah, it's part of it too. Is just that brand name for reliability. Like, we know they get used in so many different things and different applications, and they've built up, a library of the stuff works, right? And you want to be able to, if anything, you need to service it. You want to be able to get those parts relatively easily and not use some custom, very specific bearing that's really hard to get. For us, having it be reliable, and then if you do have to service it, being able to just buy it, at a parts store or on Amazon these days, this seems to be where I get Timken bearings. Stuff like that was important to us as people that have worked on all of our junk and then gone to source something one time off a 89 Bronco axle that doesn't get made anymore. And you're frustrated because you can't find it.
And then the other thing to add to that, like the reliability piece, being that we're trying to do this fairly quickly in terms of a product development standpoint, like we've got our prototypes, we're going to do some small iteration stuff, and then we want to start selling. We decided to stay very conservative on the size of our bearings, meaning they're very large. Like especially the output bearings, they're basically the equivalent of like a 14-bolt rear axle size wise. So it's like a 4-inch outer diameter tapered roller bearing. Like, yeah, you don't need to worry about that. It's going to be fine.
Cost reduction opportunity later on.
Yeah, right. Exactly. And the same thing with like our output shaft. We were originally designing for a 35 spline output shaft, and then we were like, wait, we have space for a 40 spline. Let's just do it and not worry about it.
But you need that for our little neck of the woods, and that's kind of going in the next spot. You've got a wide range of products you're going after, right, between Jeeps, Tacomas, and 4Runners. I'm looking at it more. It sounds like you got a good product going on, but our little group here runs heavy stuff, 5, 6, 7, 8,000 pound Land Cruisers. They'll be interested in this thing. Hopefully you guys spread that into it. But you got a lot of mass, and you've got a lot of velocity for around where we're driving. Going back to durability. I know we're talking about some other stuff.
Interesting.
How are we going to handle that? Make sure that's going to work.
Yeah, Matt,
it sounds like you're building in. It sounds like you're putting big bearings in. You've got big parts in to handle the big shock. Even the Tacomas here. This last weekend we were up there running. There's a lot of traction at that place, but even for them, sometimes you just got to throttle it.
Yeah, for sure.
Make sure they're going to hang in there with it.
Yeah, it's definitely something that, like, even though we're doing more slower rock crawling out here, there's times you want to be on the skinny pedal for sure and hit it. And I know that, especially as you guys get out in the South, like it's wheel speed or nothing. So that's just back to the engineering background. You got to sit down. We spent a lot of time doing the gear calculations to decide how big of teeth we needed, how much face width we needed, stuff like that. And then you do all of that stuff to make sure that the first thing that you kick off is good. But for us, like, the best way to learn whether these things are going to stand up to it is to make actual parts and go out and test them, right? And I think that's what we talked a little bit about. I don't remember at the beginning of the show or before the show about the other gears that we had kicked off. So we did a whole bunch of math to say, if we are in this application and we're going to hit it with high horsepower and try and break these things, we need a face width on the gears of a certain amount. We decided on 1.25 inches at the time. When we did that, we said these things should last forever under hundreds or whatever horsepower we decided we wanted to put it at. They should last for 100,000 miles or more on the gear teeth and seeing a huge impact load all the time. And we said, did we overdo it? Like, did we make them too strong? And like, these are going to be way too beefy. And the portal gets wider, the wider your gear is. And we want to keep it as narrow as we can. For us, instead of just going back and trying to do more and more math to see if it was right, we just kicked off a bunch of different face width gears, different size gears, basically, and different strength levels, and said, if we put these in the Jeep in the hardest application that we can come up with and just hammer on it, what happens? If we put in a skinnier gear and we hammer on it and it doesn't break, then we know we overdid it. But if it does break, then we know we're probably in the right range of like gear strength and everything else, right?
Yeah.
It's that empirical testing versus theoretical, math that we were doing in the background. Scott can tell how that worked out for us.
Well, so I do want to answer specifically. I can't tell you for sure you can, put an 8,000-pound vehicle and, go and ram it up a hill and, with 500 horsepower or whatever, because we haven't tested that. So I can't say that today. Obviously, we're going to be working with people and try and get these things out and get testing those applications. But the analysis we did was based around, we want our stuff to be stronger than the stock stuff. So where is the weak point within, a Jeep JK, for example, or a JL? And pretty much said, okay, the axle shaft torque wise is going to be the weak point. Let's just design it to where our impact load the gears will survive the impact load where the axle shaft would not survive that. So that's kind of how we designed it, and using that as a baseline for comparison. But yeah, what Matt's referring to is we had, I think you mentioned we had two different versions. We had three different versions. So like our standard 1.25 inch width, and then an intermediate one at 1 inch face width, and then the smallest one at 0.75 inches. So like, what is that? 40% smaller than our standard one.
And 80% of the face width.
Right. And yeah, a few weeks ago, I was out at a Slick Rock Trail and like rolled up to an optional obstacle and just gave it like a little bit of a bump, and you just hear like, just like gear teeth gone. And like, oh, that's not good. And we put the smaller gear teeth portals in the rear axle. So this was the smallest one was on the driver's side rear axle. And so I start to going back up, and my back left tire's not spinning at all. I'm like, oh, yeah, that's not a good sign. So then they go and drag me back, and still the wheel would not spin. And I'm like, okay, well, it's probably that portal. It's got an issue. And sure enough, and at the time too, I had a spare portal because we, were planning on this happening or anticipated that this might happen. So we swapped out the spare portal. It was like an hour or so, no big deal. Got it running again. And then the next day went and did an even harder trail, Fordyce, if you guys are familiar. And anyway, and then we took the portal apart a few days later when we got home, and just gear teeth everywhere. I mean, we fully sheared off every single gear tooth on the input gear, and then the intermediate ones, like two of them from one of them, and they had 5 off the other one or something like that. So yeah, we definitely found that is our bare minimum that you would need, or you're going to probably be in trouble. But then one other interesting thing or learning from that was that when we, because this is kind of I would say a little bit of a hasty move by us to kick off these thinner gears, and so we didn't put maybe as much thought as we should have into those. And so on the standard gears, we have these grooves that run underneath the edge of the gear. And that just allows more oil volume in there, and it kind of helps like oil the bearings. And so when we did the thinner ones, all we did was just remove one side of the gear, and we left that groove on the other side. And so when we took them apart, you could kind of see the remaining teeth like tilted to one side, to that groove side, and then failed, or seemingly then failed. So we're pretty confident that if we redid that without those grooves being under there, with a little more support under the teeth, they'd probably still be running. So that's something we'll probably come back to at some point in the future, because it would be nice to know, like, hey, really, really, what's the limit? But we can say right now, I mean, we've been running. We now have 2,500 miles on the portals, plus all these trails we've done, and the intermediate one, the 1 inch face width, still running fine. So we haven't any issues with that.
Yeah.
Awesome.
But for production, just to be clear, we're going to stick to that largest one, because we'd rather be safe,
Well, hey,
good clarification.
For the viewers and the listeners, and this is what's really cool about how transparent you guys have been with this whole company, is if you go to YouTube and you search Portal Pro Slick Rock, everything Scott and Matt just described, the whole ordeal is documented there. So it's a good little 20-minute watch. Yeah.
We love our failure analysis over here. That's just some of the best parts of engineering is just breaking stuff and then figuring out why it broke, and then redesigning
Absolutely.
it. And that's why we're doing it ourselves now before we go to customers. Is like, I don't want that to happen to anybody that ever buys a portal. I'm fine with it happening to me because I designed the things, but if these things go out in the world and that happens, it's totally unacceptable. So we're making sure that we put it as hard of a test as we can possibly put it on ourselves, and then before we even get it to anybody.
Yeah. And you talked about something a minute ago as far as your inflation system. Those aren't easy to pull off and not have some bad air leaks, and you're running compressors forever. What did you guys run into for mechanical challenges trying to make this thing work right?
Apparently, seals on rotating components with air is a
They're
big
hard.
challenge. That's hard. Yeah. Our first prototypes that we ran, we tried a couple of different X-ring or O-ring options or a double O-ring, and honestly, none of them worked. We weren't satisfied with how they worked. We got the system functional, and it was fine. And then we started to see air getting into the portals, stuff like that. So we just scrapped the whole thing, and we said we're not doing that style of seal. We switched to a full-on like rotary wiper seal, like you see on a transfer case or something like that. They do make them that are high pressure resistant, right? So you can run them up to 140 psi or something like that. That's kind of the direction we're moving to from an inside the portal perspective. The rest of the system we're still working out on how exactly we're gonna manage it as a production friendly version. But inside the portal, that's kind of the challenge we ran into in the beginning, that we're already like, all right, move on from this. Let's start something better.
Gotcha.
So yeah, like basically today our prototype technically works, but it sucks. So it's got to go through some iterations before
It's for sure
have that in customers' hands. Yeah, it's a very prototypey prototype. Yeah.
Gotcha. So you're good. Go ahead.
No, go ahead, Zach.
But you've got the portal's going to widen you, and she's going to increase your height. Are you making any recommendations to customers for what aspects of their builds should change and how they should change, and then maybe just stay away from some options because of what you're creating?
Yeah, so we touched on it a little bit already. I think the biggest thing is your wheel selection. We talked about like having a centered wheel. Like right now, what we're running, and it's partially what we're trying to find out in our testing. So we're running a 17 by 9 with 4.5 inches of back spacing. So it's pretty much a perfectly centered wheel. So that's like a pretty typical wheel that you would find on a Jeep. We're running a 37-inch tire. So we've effectively just pushed our wheel completely out 4 inches. And so far we haven't broken anything, but we've done just about every upgrade you can do to the stock Dana 44 axle. So we've got a truss across the whole thing. We've got C gussets welded on. And then we also installed metal cloak. They're super baller joints, I think they're called, the ball joints. And we thought that was going to be the problem, that we were going to rip those things out. And so we just started with something that we knew was going to be a high quality product. That would our recommendation would be all the kind of known weak points, especially for JK Dana 44s and JL Dana 44s, the ball joints, the strength of the axle tube. That's where we would recommend. If you want to do the stuff that we've been doing in our videos, you're going to the big trails and hitting big obstacles, definitely think about those things. And then the other one that we were talking about is the wheel selection. And it's something that we're dabbling. Like I said, we're making our own custom offset wheels. And we're debating if we want to get into offering our own wheels or partnering with a company, because it is a different size or offset of wheel than you would typically get for a off-road application. So those are the kind of conversations we're going to be having.
Yeah, I think I'd add to that too, that a lot of those things that are prone to fail on the Dana 44 stock axle, if you're going to run 37s or 40s on it, pretty much everybody recommends those things anyway. A lot of people are putting trusses on and C gussets just because that's just where those things fail. I think the other part of it too that a lot of people are concerned about with portals is you're lowering that whole output, and you're putting a lot of leverage down low on the ball joints. For us, the solution to that was just to include some extra brackets that tie the bottom of the portal into, on the JK in the rear, it's a shock mount that's right next to it. So you get that lateral load support. And then on the front, it just ties directly to the lower ball joint nut, lower ball joint basically, and then bolts to the nut. So you get all that. You have all the strength up here that you're replacing your unit bearing with, but you also have an additional bracket down low to resist any leverage from when you're getting into a squeeze or something like that that's pushing on it, or you're trying to pull the wheels out, stuff like that. And the brackets that we made and then we'll plan to ship with all the portals will be have been doing great so far. So been pretty happy with them. and we've put that thing in.
Especially, I was gonna say at Sand Hollow, I mean, we went through some like nasty notches and things that were just like, it was squeezing like everything so bad. Even just watching people around us go through, I'm like, oh my god, they're gonna DB a tire right there. Oh wait, I have to go through that right now. And then we pull through, no problem. So yeah, it's been proven okay so far.
Good deal.
Guys, what about so if somebody makes an investment in these, obviously it's, unfortunately they're not magic. You can't just put them on and forget about them for the next 5 years. What do we need to know from a maintenance and kind of service standpoint on them?
Yeah, for sure. So if you imagine just like your ring and pinion and your differential, gear oil changes, regular servicing there, eventually bearings, things like that get worn out. The gears themselves, we don't expect to really be an issue. Like they should functionally last more than 100,000 miles or so, but your gear oil changes will be about as often as you would expect to change a differential. So every 20, 25,000 miles is kind of what we're shooting for. Right now, obviously, we're 2,500 miles in, and we're keeping track of all of our oil changes, and we have taken samples at regular intervals to then send out to a lab and do analysis to make sure that we're not losing a bunch of material. But even just like the magnet drain plug is showing us that it's not going to be too big of an issue. But things like that, regular oil changes, and then eventually, bearing replacement is a very long-term maintenance item, but for the most part, that's about it. If you had basically like a differential or even a transfer case, however often you're servicing those things is kind of a similar setup, right?
Mm-hmm. Yeah.
Yeah, and then we've been collecting. We just started collecting temperature data for our oil because we want to see, because you can basically partially predict the life of your oil based on the temperature you're seeing. So in a transmission, if you're running 250 degrees all the time, you're going to want to change your transmission fluid more frequently than if you're running 190 degrees, something like that. And so we put in thermistors to measure the temperature in the whirls on all four corners with a data acquisition system that we have. And we're not even seeing temperatures above 200 degrees Fahrenheit. So we drove straight out 650 miles to Sand Hollow 2 weeks ago, and it was 100 degrees the whole time we were driving. And the peak temperature we saw was like 198 degrees in the oil. So that's just kind of an indication. Yeah, yeah. So it's kind of an indication that we're not really overworking, if you want to say that, the oil. So shouldn't be like too frequent to change the oil.
Cool. All right. Well, gentlemen, this has been fun. I hope you guys enjoyed it.
Yeah,
definitely.
But before we let you get out of here, we've got to wrap up with our rapid fire questions. So we'll go down the list here, and let's see. Scott, we'll start with you on each one.
Okay.
So
good.
Zach, go ahead and get us started there.
What's your go-to trail snack? You're stuck in the cab all day. What are you going for?
Nothing interesting, just like pretzels or a Cliff Bar. I'm pretty lame.
That's such an engineer answer to the snack. Yeah,
it's practical. Yeah,
yeah.
I was raised as the calories don't count when you're wheeling.
There you go.
For me, it's any sort of like candy, gummy candy, sour candy, stuff like that is like in the center console, just like in the middle of the day. I'm after it.
There you go. I hear you.
All right, Scott. If you can only listen to one artist or one album while you're on the trail all day, what's going on repeat?
I think, man, that's a tough one. I would say like Passion Pit. I'm a big like kind of that, I don't know if you guys are familiar.
I don't know Passion Pit.
Wow. Okay. It's I don't know how to describe it. It's kind of poppy rock, alternative, whatever.
Okay.
Yeah.
for me, it's gonna depend on who's in the Jeep with me. If
There you go.
if I got my son with me, it's gonna be like Bluey or a Disney thing. I'm not gonna like it, but that's what I'm gonna get.
Yeah.
And I might upset some people with this, but I'm a big Taylor Swift fan. So if I've got Taylor Swift on all day, I'm honestly gonna do that anyway. Like if I have to be stuck with something, I'm already doing that.
This may be the most controversial statement ever made on this show.
Yeah.
Is T Swift? Yeah.
Definitely doesn't fit the rest of the persona sitting in the shop working on this Jeep.
Oh, that's funny.
Yeah.
All right, Scott. Your favorite binge watching TV show?
Ooh, it's probably going to be The
Or
Office.
current one.
Like, yeah, current one. I actually just watched a show called Dark Matter, which is like kind of a multiverse, but like science-y kind of version as opposed to like the Marvel whatever. That was really interesting. But if it's just like my wife and I don't know what to watch, it's either South Park or The Office.
Classic.
Fair.
Yeah. I'm in the same boat. It's The Office, or it's like Brooklyn Nine-Nine or something like that. It's just like I need a good, keep me happy kind of show, you know. It's been a long day.
Yeah.
Yeah, I'm with you guys on the Dunder Mifflin binging there. Yeah.
Yeah.
All right. This is a very important question. DeWalt or Milwaukee?
Or door number 3.
Or door number Matt's already showing it there.
Yeah.
Am I allowed to decline to answer? None of the above. I'm door number 3. I'm the green guy. I'm a green guy.
Oh,
Ryobi man.
Oh, okay.
For so long. I don't know how he does it.
Actually, you know what though? I've had no Ryobi tools fail, and I had 2 DeWalt angle grinders, and one of them just crapped out on me. So
that's because the Ryobi tools don't have enough horsepower to fail.
Oh,
that's what he said.
It's the Toyota strategy.
That's funny. That's that's interesting. That's I like it, Scott. That you are the first door number 3 contestant on the show. Yeah, I knew it would happen one day. So there we go. Yeah.
The problem is once you buy the batteries, you're stuck. You know, it's like can't redo this whole thing. So now I'm just in it.
Oh man. And your last one, what's your go-to karaoke song?
I have no idea. The last time I did
karaoke. Your last time in China. Your last in a
yeah. I used to travel to China a lot for work when I worked at Apple, and I mean, I'll tell you, there was maybe a few beers had been consumed. So I'm not exactly sure what we were singing, but I'm quite sure that I was feeling overconfident and singing very loudly. But I couldn't tell you a song that I would sing for karaoke.
All right.
My experience with karaoke is similar-ish to Scott's, where I've never done karaoke in the United States, but in China, yeah, I've done a few China trips and done it there. The crowd favorites are always, for some reason, classic American country songs. So John Denver is like my go-to, an easy to sing song, and everybody for some reason knows the words, even though they're on the other side of the world.
Well, I thought for sure you were going to say Taylor Swift, but John,
it is Taylor Swift. But I again, like Scott, I need to be a few beers in to like hit the octave range for Taylor Swift.
I see.
Yeah.
All right, guys. Thank you all again. We wish you the best of luck with this endeavor, and let's keep in touch and keep people informed on how this works out.
Yeah, it sounds great.
That's great. Thanks, guys.
Yeah. Thanks, guys. Really appreciate it.
See y'all.
Yeah, you're welcome. Have a good one.